Welcome back to Year 9 Chemistry. This is Week 1, Session 2, Changes of State, Diffusion, and Density. Last time, we met the particle model. Today, we put it to work, explaining how substances change state, why smells drift across a room, and what makes one material denser than another. Let's dive in. Here are your 4 goals for this session. First, explain melting, freezing, evaporation, boiling, and condensation using particles. Second, distinguish evaporation from boiling. That is a classic exam question. Third, use diffusion as evidence that particles really do move. And fourth, calculate density with the formula ρ equals mass over volume and connect it to particle arrangement. A change of state is a physical change. The chemical identity never changes. Water is H2O as ice, as liquid water, and as steam. Here are the 6 changes. Melting takes a solid to a liquid, and freezing reverses it. Evaporation and boiling take a liquid to a gas, and condensation brings the gas back to a liquid. Some substances can even sublime straight from solid to gas, or deposit from gas back to solid. Heating transfers energy to the particles, so their motion increases and attractions can be overcome. Cooling removes energy, so motion decreases and attractions organize the particles more closely. Now for that classic exam distinction. Evaporation happens only at the surface of a liquid, and it can happen below the boiling point. That is why puddles dry even on a cool day. The fastest particles escape first. Boiling is different. It happens throughout the liquid, at the boiling point when bubbles of vapor form everywhere inside the liquid. And remember, both are physical changes, not chemical changes. Diffusion is the net movement of particles from a region of higher concentration to a region of lower concentration. Watch the purple particles. Each one moves randomly. No particle chooses where to go, but random motion spreads them out until the distribution becomes more even. A smell crossing a room is evidence that gas particles move. Purple potassium manganate 7 spreading through still water is evidence that liquid particles move too. How fast is diffusion? 2 rules. First, diffusion is faster in gases than in liquids because gas particles move more rapidly and have larger spaces between them. Second, diffusion is faster at higher temperatures. And be careful with the reason. It is because the particles have greater average kinetic energy, so they move faster. The particles do not get bigger. The attractions do not disappear. The particles simply move faster. Now for density. Density is mass per unit volume. Rho equals m over v. Common units are grams per cubic centimeter and kilograms per cubic meter. Here is a worked example. A metal block has mass 54 grams and volume 20 cubic centimeters. Density equals 54 divided by 20, which is 2.7 grams per cubic centimeter. In the particle model, closer packing usually gives a higher density. Your turn. A liquid has mass 45 grams and volume 15 cubic centimeters. What is its density? Pause the video and calculate. 45 divided by 15 gives 3.0 grams per cubic centimeter. One more. Mass 36 grams, volume 12 cubic centimeters. Pause and try it. Again, 3.0 grams per cubic centimeter. If you got both, the formula is yours. Here is a beautiful exception. Ice floats on water, so solid water is less dense than liquid water. Why? When water freezes, its molecules lock into an open structure with more empty space than in the liquid, so density depends on chemical structure, not just on closeness of packing. And one misconception to clear before we finish. Temperature measures the average kinetic energy of the particles. It is not a measure of how much heat a substance stores. Quick check. Question 1. What do we call the change from gas to liquid? Pause and answer. Condensation. Question 2. Why does diffusion speed up when it is warmer? Because the particles have greater average kinetic energy. Here is your recap. Changes of state are physical, so the identity stays the same. Evaporation is a surface process that can happen below the boiling point, while boiling happens throughout the liquid. Diffusion is the net movement from high to low concentration, driven by random motion, and density equals mass divided by volume. Next session, mixtures, and how to choose the right separation method. For the full course, with practice questions and the final exam, visit www.bridgetoexam.com. See you in session 3.